Hello everyone, welcome to Grade Up. We are here again with the course on strength of materials. In the last lecture, that was the introductory video, we saw about the syllabus, what we are all going to cover in this, and also the weightage analysis of this particular subject in the GATE examination after 2015 till 2018. So we will be starting with some of the basic concepts which will be useful throughout this subject or for all the topics that we are going to cover. The basic concepts will be taken in two parts, one in this lecture and one half will be in the another lecture. Okay, so let's start basic concepts part 1. First of all, we need to understand that what are the basic requirements of a machine component. Okay, any machine component must satisfy these requirements. The first of all, the requirement is that it should have high strength. Obviously, the strength of any machine or any machine component must be high. Otherwise, if the strength is not high, the machine will succumb to failure or fracture. Similarly is the case for high rigidity. The machine component must have high rigidity also and high service life. Okay, because the machine components or the machine overall has huge money that is invested into it, so it should not be for a shorter duration of life, it should have a long duration of life. So the high service life, then the less weight. Why less weight? So that if it is required, so that it can be transported easily. Okay, and also the less weight has other factors associated with it, that if it has got less factor, then the cost incurred will be less. Why? Because the materials or the components that are inserted into it or the minute details that it carries is also less, then only the weight will be less. So these are some of the basic requirements of a machine component, that is, it should have a high strength, high rigidity, high service life and less weight, and the cost should also be less. Okay, then we move on to the criteria for designing of any component or any member or any element. Okay, so there are two criteria for design. The first is based on the strength criteria and second one is based on the rigidity criteria. Okay, so we will take them. What are them? We will take them one by one. So starting with the strength criteria, it is based upon permissible or allowable or design or working or safe stress. These are all the names that is for a single entity, that is, you can call it by the name of permissible stress, allowable stress, design stress, working stress or safe stress. What is that? We will going to take it when we will introduce the concept of factor of safety. Okay, so according to this strength criteria, the criterion is that the maximum stress that is being induced into any system, okay, or any component of any machine, this must be less than the permissible stress. Okay, the very safe condition is that it should be less, but the limiting value of this maximum stress can also be equal to the permissible stress. But in any case, if the maximum stress becomes greater than the permissible stress, then failure will occur. Okay, so maximum stress induced must not be in any case greater than the permissible stress. Till that part of time when we will introduce the concept of factor of safety and get to understand about the permissible stress, you can take it as that way, that permissible stress is that stress beyond which the stresses induced in a system must not cross or must not go. The stresses induced in any system or any part of the system or any machine component must not go beyond the permissible stress. Okay, then what is stress? Okay, please hold on, that we will take up later. What is stress? You might be knowing it, what is stress, but we will take up it in a later part because it contains some basic details to understand that what is stress. Okay, Then second criteria is based upon the rigidity, that is known as the rigidity criterion. So that is based upon the permissible deformation. Okay, the strength criteria was based upon permissible stress, whereas the rigidity criteria is based upon permissible deformation. That you need to note down here only. Okay, so in this case again the maximum deformation induced must be less than the permissible deformation. Means the permissible deformation is that maximum value of deformation up to which we can extend, okay, the deformations that are being introduced or induced in the system, till which the failure or the fracture of the component will not occur. If the induced deformation within the system, they go beyond the permissible deformation, then the failure may occur or even the fracture may occur. Okay, so its limiting value, it can be equal, but similarly as the strength criterion, it must not be or never be greater than the permissible deformation. Okay, so these are the two criterions you need to remember. That strength criteria is related to stress, okay, the stress induced, and the rigidity criterion is related to the deformations. Okay, is related to the deformations. These 2 points you must note down here itself. The next, now we introduce the concept of factor of safety. Okay, what is that? First of all, factor of safety denoted by capital N, or like this also FOS. Okay, what it is used for? It is used to determine permissible stress. Okay, and also to get the same dimensions based on strength criterion, because there we have used the concept of permissible stress. So factor of safety used to determine the permissible stress, and hence to get the same dimension based on the strength criterion. Okay, so now it's defined as, the factor of safety is defined as failure stress upon permissible stress. Okay, so failure stress is that stress at which failure will occur. Okay, at which failure will occur, and the permissible stress is that up to which we can extend the stresses that are induced within our system or the any machine component. Okay, then what are the failure stresses in different kinds of loading and also related to different kinds of material. Okay, so for a static loading, what is static loading? Static loading means that it is neither changing or means constant in magnitude as well as direction. That is known as a static loading. That means neither its magnitude nor its direction is changing with time. So static loading, if it is a case of a static loading undergone by a ductile material. Okay, ductile material. So in that case the failure stress is the yield stress. Okay, yield stress denoted by S subscript Y. It can be SYT, it can be SYC, or it can be SYS. This is for tension, this is for compression, and this is for shear. Okay, this is basically the simple notations. Okay, what are all these? We will see when we move ahead with the course. Okay, then in that case the component should not undergo permanent deformation. Okay, if it is a case of a static loading undergone by a ductile material, yield stress is the failure stress, and the material or the component should not undergo permanent deformation. Permanent deformation means that if there is a component, we apply some kind of a force to it and then we leave that force or remove that force. So after the removal of the force, the body or the component attains its original position. Okay, if that happens, that means there is no permanent deformation. Okay, then another case, same case of a static loading, it can be undergone by a ductile or brittle material. In that case, it is ultimate stress. Okay, and in this case the failure should undergo permanent deformation. Okay, in that case permanent deformation is allowed. In this case the permanent deformation is not allowed. Okay, permanent deformation not allowed, permanent deformation allowed. And in case of a fatigue loading, the failure stress is the endurance limit. Okay. Simply you can note down here that static loading means which is constant both in magnitude and direction with respect to time, and in fatigue loading there is a change, maybe it is in magnitude or direction or both with respect to time. So the force that is not static, that is which is dynamic, that is known as a fatigue loading, and in this case the failure stress is the endurance limit. What is that? We will look up. Okay, see, from this expression you can see that the permissible stress is directly proportional to 1 by n, okay, for a given material, because for any given material the failure stress is constant. Okay, so if we remove that constant, we are left with sigma permissible, that is permissible stress is proportional to 1 by n. So from this expression you can see if the factor of safety is high, okay, if the factor of safety is high, that means sigma permissible, that is permissible stress will be low because they are inversely proportional to 1 by n. And if permissible stress is low, then dimensions will be high. Okay, how? See, because what is stress? Stress is equal to, let us say, upon some force upon then area. Okay, and if we consider a circular rod, suppose we consider a circular rod of diameter d, okay, so in that case the area will be equal to what? Pi by 4 d square. So in this case you can write this as 4f force upon pi d square. So you can see that from this sigma and d, that is sigma is proportional to 1 by d square. So they are again inversely proportional. So if the sigma permissible, that is permissible stress decreases, then the dimensions of any component will increase. So if the dimensions increase, then what happens? The safety of the component will increase because we are using higher factor of safety and we will get the low permissible stress. Okay, and the cost will also be high because we are using the higher dimensions. Okay, as the dimensions of any system will increase, that means more material is required for its manufacture, so the cost will also increase. So increasing the safety, it is a desirable phenomena. Okay, because in every machine or in every component we require that the safety should be there. So increasing the safety is a desirable phenomena, but on the other hand the increase in the cost is an undesirable phenomena. It is an undesirable phenomena. So we cannot use a very high value of factor of safety also because of this reason. Then what happens if we use a low value of factor of safety? See, all the effects will be just opposite to this case. If factor of safety is low, sigma permissible, that is permissible stress will be high because they are inversely proportional. Then dimensions will be low because these two are also inversely proportional. I have seen here. Okay, then in this case safety will reduce and the cost will also reduce. So safety reducing is an undesirable phenomena in this case. Okay, whereas increase in the cost, that is a desirable phenomena. Okay, so the safety and the cost of any component or any part of the system or any machine that are inversely proportional to each other. If the safety, if you need to increase, have higher safety, then the cost will also increase. Okay, and if the safety, if the cost, you need to minimize the cost, then safety of any machine component will also decrease. So we have to optimize the use of factor of safety. We cannot use a higher too high value also, and we cannot use a too low value also. Because why? Because we have seen. Okay, then comes another term that is known as margin of safety, denoted by capital M. What is that? Margin of safety is given as n minus 1, that is the factor of safety minus 1. Okay, if the factor of safety is equal to 1, then M, the margin of safety, will be equal to 0, and that is the failure design, because factor of safety is equal to failure stress upon permissible stress. Okay, that is the permissible stress, and when the factor of safety is equal to 1, that means the failure stress is equal to permissible stress. That means when we are making our machine or our component undergone some such loading conditions or such working conditions that its permissible stress is equal to the failure stress, and if, because we have seen according to the strength criteria that sigma maximum induced must be less than equal to sigma permissible, and if the factor of safety is equal to 1, then this becomes equal to sigma failure. So if in a case of any mishap or any accident, what happens if the load increases somehow, because stress is equal to load upon area or force upon area, so stress can be increased by if the force increases or if the area decreases. So if anyhow due to any such conditions or any such what you can say, the carelessness or something like that, if anyhow the force increases at any instant or the area decreases at any instant, then this sigma or the stress induced will become high. And if we are using the permissible stress that is equal to the failure stress, so at that instant, as soon as the maximum stress induced becomes equal to or greater than the sigma failure, that is the failure stress, the component will at once fracture or fail completely. So to avoid that, we use factor of safety, and we use a factor of safety that is greater than 1 always. Okay, we do not use a factor of safety equal to 1 even by the reason for that I have explained you. Okay, so factor of safety equal to 1, that means that margin of safety equal to 0, that is the failure design, because in that case how the failure will occur that I have told you. And if the factor of safety is greater than 1, then margin of safety will be greater than 0. Okay, and this is the safe design. So what we intend to do, or what our intentions are, that we need to keep the factor of safety higher than 1 and the margin of safety higher than 0. Okay, then why this margin of safety is used, that I have told you, to avoid accidents. Okay, that already what we have written here. Factor of safety is provided in the design of a machine, okay, component, to ensure some amount of reserve strength. What is that reserve strength? Failure stress minus permissible stress. Because if the factor of safety is higher than 1, that means failure stress will be higher than the permissible stress. So there will be some, the difference of both of them will give us some kind of a reserve strength, so that if our force increases, load increases, or the dimensions decreases and the stress induced increases due to them, so there will be some kind of reserve that we can go by, or we can stretch our component to that without going into the failure zone. Okay, and in the component in the case of an accident, that I have already told you. Okay, so now you have, as you have understood very clearly the concept of factor of safety, we will move ahead and see what is load. Because without load, or without understanding the concept of load, the subject of strength of material cannot proceed further. Okay, so load is defined as an external force. First of all, you need to understand external force or a couple. Okay, what is a couple? Couple is two equal and opposite forces separated by some distance. Okay, so if this is force F and this is also the force F separated by a distance, say A, so these two forces, that is F into A, will be equal to a couple. Okay, so the load can be defined as any external force or a couple to which a component is subjected during its functionality. Okay, example, it is a weight of a component with respect to another component, or the centrifugal forces, the inertia forces, the gas load or the fluid force, the wind forces, the belt tensions, the twisting and the bending couples. Okay, let me give you an example. See, let us say this is a shaft, okay, and this is held by one bearing here, this is held by another bearing at this end, and this is a rotor that is attached to the shaft. Okay, this is a shaft and this is the rotor. Okay, So when we are considering, please listen carefully, very important concept regarding loads. When we are considering the shaft, only the shaft, if we are taking the component as a shaft, then what will act as the load for it? When we are considering just the shaft, the weight of rotor, that will act as the load for the shaft. And when we are considering the bearings, because there are also the whole mounting is on the bearings, so when we are considering the bearings, then the weight of rotor plus the weight of shaft, both these will act as the load for the bearings, and for the shaft only the weight of the rotor will act as the load. Okay. Then force. There are two kinds of force that we will be dealing with. The first one is the surface force and second one is the body force. What is a surface force? That is distributed over the area. Okay, by the name surface only you can understand, very simple, that is distributed over the surface. Basically it's a two-dimensional, okay, it is in a two-dimensional. Then the body force is distributed over the volume of a body, that is the three-dimensional. Okay. Then there are some assumptions that is made on a strength of material equations. Why assumptions are needed? Because whatever we are studying, we take some assumptions, because in a practical working of any component or any machine, the many external factors also act, okay, which we cannot include in our course during this time. Why? Because there are some such causes which requires a very high level of learning. Okay, so they are not introduced in the graduation level and not included even in the GATE syllabus. They are the part of the research. Okay, so we need to make some assumptions. And what are those assumptions? That the material is assumed to be both homogeneous and isotropic. What does these two words means? Although we will take them up later also, but let me give you a brief idea about it. Homogeneous means that its composition is uniform throughout. Okay, the composition is uniform throughout. That is the meaning of homogeneous. And the isotropic means the properties are independent of direction. Means the properties, any properties, okay, they should not be direction dependent. Okay, they should be independent of direction. Second thing, the component is assumed to be prismatic. What does the word prismatic means? Prismatic means that the cross-sectional area is same throughout its length. Okay, that means like this, if it is suppose a bar, so its cross-sectional area is constant throughout, like this. Okay, and if it is a circular rod, like this, so here also its cross-sectional area is constant all throughout. So that is the meaning of a prismatic. Okay, then effect of body forces are neglected. Okay, because if there is any component, okay, then it will have some weight, and due to that weight or due to that mass, there will be some body forces also acting on it. So the effect of those body forces are neglected. Okay, then load is assumed as a static load. So that means that if the body forces are neglected, effect of body forces, we consider the effect of only the externally applied load. Okay, then the load is assumed as a static load. What does that means? Again, I have told you static load, magnitude and direction not changing with time. Then the material obeys Hooke's law. What is that Hooke's law? That we will take up later, but that simply says that up to the proportional limit, the stress induced is directly proportional to the strain. Okay, but as though the stress strain, what is proportional limit, you do not need to worry about. That we will take up in a very detailed manner when we will talk about the stress and strain. Okay, till then these are the 5 assumptions that is to be made: that the material is assumed to be homogeneous isotropic, the component is prismatic, body forces effect neglected, load is assumed to be static, and the material obeys Hooke's law. So next, the classification of loads. Okay, that the loads, there are 3 bases on which the loads are classified. The first one is the with respect to time, second one is based on the direction, and third one is based on the distribution. Okay, so with respect to time, there are static loads and dynamic loads. So what is a static load? That is a dead load, okay, and the gradually applied loads. Then according to the static load, means other than static load is dynamic load, which changes. That is the impact load, also known as suddenly applied or shock loads, or it can be fatigue, cyclic, or variable loads. What are all those? We will look up, no matter, no problem. Then based on the direction, that is the normal load or the shear load. The normal load means that it is acting, if this is the cross sectional area, okay, this is the cross section, so it is acting perpendicular to the cross section. Either it can be like this, means it can be tensile, or it can be compressive force. Okay, it can be tensile or it can be compressive. So that means which is acting perpendicular to the cross section. If this is the cross section, so if it is acting either outwards of this or inward of this, so that is known as the normal load. Then what is the shear load? Shear load means the load that is acting parallel to this surface. If this is the surface, that means if this is the cross sectional area, so it is acting parallel to this. Okay, this is acting parallel to this, either this way or it is this way. That is known as a shear load. So the normal loads are again classified into 2 categories. One is axial loading or the eccentric loading. The axial load means that if this is the component, the cross section, okay, if this is the cross section and this is the center, means this is the axis, the central axis, so if it is acting this way, this is the axial load, means acting right from the center, either outward or inward. Then if it is acting at some another point that is not at the center, so that is known as eccentric loading. Okay, means that is also acting if see, let me explain. If there is some point like this, this is the center. If the force is acting directly on this point, can be outward or can be inward, that is known as an axial loading. If it is acting at some other point other than that, okay, some other point other than that, means shifted from that center either outward or inward, that is known as an eccentric loading. And then they again can be classified as tensile load or compressive load. Tensile load means out of the surface or out of that cross sectional area or into that surface, that is compressing, that is known as a compressive loads. Then based on the distribution of load, we have the concentrated loads and the distributed load. Concentrated load means that they are concentrated at a single point. The concentrated point load or the concentrated moment means they are concentrated at a single point. Then distributed load means that is UDL, uniformly distributed load, or UVL, uniformly varying loads, or UDM, that is uniformly distributed moments. Okay, I can explain to you all these terms here only, but I don't think that you will understand if you haven't gone through this subject properly earlier. So you might not know what is a cantilever beam and all those things, but again let me make you clear without using those terms. If see this is a shaft or this is any beam, okay, so if there is a uniformly load acting over this, okay, if there is a uniform load acting over this like this all throughout its length, so this is UDL, that is uniformly distributed load. If again there is a same bar or the same shaft and there is a load acting like this, that means starting from here from 0 and going up to some maximum value at this point, the load is increasing constantly or uniformly it is varying. So this is known as uniformly varying load. Then what is a uniformly distributed moment? Again this is a beam. So if there is a moment that is applied, constant moment that is applied at each and every section of this beam, that is the all having the magnitude as m, okay, So this is a uniformly distributed moment. Okay, so these are some of the classification of the loads based on time, direction and distribution. These all will be used in this subject completely, means throughout the subject all these terms will keep on coming in front of you, that static loading, dynamic loading, axial load, eccentric load, concentrated point load, UDL, UVM. So you need to keep in mind. So this table or this diagram is very much important. You must know all the terms which are written here. Okay. So next is, we talked about the dead load. This is the dead load. That means with respect to time, its magnitude is not changing. It's a constant magnitude. Okay, so this is a dead load. What is the meaning of a gradually applied load? Gradually applied load means it starts from 0 and it reaches a maximum value in some duration of time, and after that its magnitude remains constant. Okay. So in that case, that is known as a gradually applied load, and gradually applied load is considered as static because delta P, if you take any small time duration delta T and in that time you take delta P, so delta P is small with respect to time. Okay, so delta P is small in case of gradually applied load. Then the next one we talked about, okay, first of all take this. Any gradually applied load is represented by its maximum magnitude. That means if we are talking about this gradually applied load which is increasing from 0 reaching the maximum value P, so the gradually applied load will be represented by this magnitude P. Okay, and the work done by P will be equal to, because these are the deformations if we take, so these are the deformations, so that will be given by half P into delta. That means the area of this shaded region. Okay, the area of P versus delta curve. Then another kind of load, impact load. What is that? It is a load which is acting for a short interval of time, that is time taken to reach the maximum magnitude is less. In this case also the same thing happens as in the case of gradually applied load, but the magnitude, the highest magnitude it reaches, that is less as compared to in the case of gradually applied load. If we draw the gradually applied load also in this case reaching the same P max from 0, it will go something like this. Okay, something like this. So this is the time duration that will be required for the gradually applied load, whereas the same magnitude of maximum load has reached in a short duration of time in the case of impact load or the suddenly applied load, also it is known by that name. So in this case this load is considered as dynamic because delta P is considerable with respect to time. That means the delta P is very high. If you take the same time interval, the delta T, okay, as we have taken in the case of gradually applied load, comparing both of them, we will see that the delta P is very high in the case of impact load. Okay, and then what will happen? What will be the deformation? This is the symbol for deformation. Okay, for impact loading will be equal to static loading or static deformation into the impact factor, and the impact factor is always greater than 2. Maybe it is equal to 2, limiting value is 2 and greater than 2. So this is for the deformation. Similarly for the stress also, that is in the case of impact loading, the stress induced are equal to impact, means the stress induced in the static into IF, that is the impact factor. Okay, next, fatigue load. What is a fatigue load? Fatigue loads are those loads whose magnitude or direction, or both magnitude and direction, changes with respect to direction and they are applied with respect to time. So their magnitude is changing with respect to time and their direction is also changing. Okay, so if it is a case of like this, in this case the force is changing from plus P to minus P. That means this is the case of plus P, means it is a tensile force of same magnitude and it is a compressive force of same magnitude. That means in this case the force, the magnitude is constant but its direction is completely getting reversed. So this is a case of completely reversed loading or completely reversed fatigue loading. Okay, in this case what is happening? The direction is not changing. You can see that it is P to P by 2. That means the tensile force was P, then reduced to P by 2. So this is the case of, what is this is the case of? This is the case of alternating stress or alternating fluctuating fatigue loading. Okay, and this in this case, the force, the magnitude is also changing and the direction is also changing. So change in direction as well as magnitude. This is the case of fluctuating fatigue load. Okay, this is the case of fluctuating fatigue loading. Okay. Then we saw that the failure stress in case of an fatigue loading is endurance limit. So what is that? Endurance limit is defined as the maximum value of completely reversed stress that a material can withstand for an infinite number of cycles without a failure or fracture, that is without a crack formation. Okay, so if sigma induced is less than the endurance limit, then it is infinite life, and if sigma induced is greater than max endurance limit, then it will be finite life. And what is that infinite or finite life? It is basically 10 to the power 6 cycles, because it is said about the completely reversed stress. So changing the magnitude of the cycle, means that changing the magnitude of load from one value maximum to another value maximum in the opposite direction, that will constitute one cycle. So if any material crosses 10 to the power 6 of those cycles, then its life is considered to be infinite, because as such there is nothing, the terms like infinite does not occur in case of the life of any material. All the component has a finite life, it is going to end somewhere. So the criteria for infinite life, what we are talking here, is 10 to the power 6 cycle. So this is about the endurance limit, that is the failure stress used in the case of fatigue loading. Okay, so these were some of the basic concepts we have started with, the types of loads, forces and all in this lecture. In the next class we will take some more other things. What are the kinds of other force or other loads that a material or a component can be subjected to. Then from the next class, the third class from now, we will be starting with the concepts of stress, strain and all those. Okay, till then, if you have any queries, any doubts, although this subject hasn't progressed too much yet, but still you need to catch up the subject right from the first lecture only, because after that it becomes a troublesome work to get all the lectures done at one time. At the end, when you have 30-40 lectures of any subject, then it becomes very difficult to catch up with. So right now, start from this lecture today only and try to get the concepts right first of all, and then when we will move on to that part, then try solving as many problems as you can. If you have any queries, any doubts, you can write to us on the GradeUp app and on the website. Your feedback is always welcome. See you in the next class. Till then, thank you. Bye bye.